Okay, so for the term project, I chose the topic of an L bracket, something we all analyzed in our last homework assignment. I plan to take that analysis further with the use of hand calculations, more accurate boundary conditions, finer meshing around key areas, and I'll also include multiple design iterations to improve upon the original basic L bracket design that we studied in class. Brackets are a pretty ubiquitous component in the area of engineering. They have a wide application and can be found in countless ranges and sizes. For such a common component, I felt it would be valuable to gain a better understanding of their behavior and gain a bit more insight about them. I found some resources that gave some background information on estimating a free body diagram and determining the maximum stress for an L bracket. Also, some standard L bracket designs, what's out there in the industry, something just basic that you can pick up from Home Depot, what exists and what sort of improvements that exist over the standard L bracket as well. To ensure a more in-depth analysis for the L bracket, hand calculations will be used to determine the maximum stress in the L bracket, which will be compared to the FEA model for the validation. For a more accurate model, a finer mesh will be used around the key areas of the bracket, like the bolt holes and the 90-degree corner. And lastly, to provide a realistic model, the boundary conditions will be thoroughly considered. The way the bracket interacts with the loaded and mounting bolts must be accounted for realistically as possible. So if the bolt contacts the bracket, the boundary conditions have to account for how that bracket and the bolt interact. For all design iterations, the following parameters will be used. The loading and mounting conditions will be universal, along with the material properties and basic bracket dimensions. And to calculate the stress at the 90-degree corner, the horizontal half of the bracket will be treated like a cantilevered beam. The two loaded bolts will produce a reactionary moment at the 90-degree corner. Calculating the stress for a cantilevered beam is straightforward enough process. The moment of inertia for a rectangular beam can be found, and the stress can be found from there. Next is a little hand calculation, just a basic diagram of how the L bracket is being loaded and how I calculated the stress at the 90-degree corner. There will be multiple design iterations based on the basic L bracket. Each design will be analyzed and compared. Designs will increase in complexity with the intention of increased performance, and each design will have information on it, including weight, so the application of each bracket could come into play. In the next week, I plan on getting the basic L bracket model completed with improved boundary conditions and meshing. The stress will also be validated with hand calculations. Once the basic L bracket is modeled successfully, the other STL CAD files will be loaded into COMSOL and analyzed in the same manner, and the improvements will be found. And that's it.